So now we've got a fully trained model on the full training data set, aka 10,000 images, because if we look at X, we've got 10,000 images and labels. Now let's use our fully trained model to make some predictions on the test data set, which is also about 10,000 images. We'll have a look at that in a second. But let's come up to Kaggle and see how they want our predictions to look. So a submission file. For each image in the test set, you must predict a probability for each of the different breeds. The file should contain a header and have the following format. So we need ID, dog breed 1, I'm not even going to pretend I'm going to try to pronounce that once again, Afghan Hound, Yorkshire Terrier, and then the prediction probabilities for all of those. All right. Now it says multi-class log loss. That's just the prediction probabilities for each dog breed. Create another header section, making predictions on the test data set. Now, I want you to have a think before we go through the code. What did we have to do to train our model on the training images? Again, pretend this is data agnostic. Whatever data you're working with, whether it's text or audio or images or video or something like that, what is our rule before we can use it with a machine learning model? Or in our case, a deep learning neural network. We've got to convert it into numbers. So that's what we have to do. The exact same data type that our model was trained on. So the data batch up here, the data batch of images. We need to create one of those out of the test images so that we can make predictions on those images. So we'll write ourselves a little note. Since our model has been trained on images in the form of tensor batches, to make predictions on the test data, we'll have to get it into the same format. So if we come back to our graphic in Keynote, remember how I always said we're focusing on the input, so aka getting our data into the right shape for our machine learning algorithm, and then making sure the outputs are correct. This is what we focus on in the beginning. This has already been implemented for us in quite a large way. As we get deeper and deeper, as you get into further projects, then you might want to start diving into this. But for the time being, and for approaching your first projects like we're doing now, you're going to be focused on inputs and outputs. Now, a little tidbit here is, again, our functions coming in handy. Luckily, we created create data batches earlier, which can take a list of file names as input. If you don't remember, go back up to where we create data batches and convert them into tensor batches. So what steps do we have to do to make predictions on the test data? Let's write those down. To make predictions on the test data, now this is kind of what I do with a lot of my projects, is just talk myself through it. The rubber ducky technique. So get the test image file names. That'll involve us writing just a little list comprehension like we've done before to access the test, go through all the files in here and save the file names to some sort of list. Yep, we can do that. And then we got to convert the file names into test data batches using create data batches. And setting the test data. Remember how we created parameters in create data batches? If you don't, that's okay. We're going to see in a second. Parameter to true, because why? What's different about our test data to our training data? There's no labels with the test data. So since the test data doesn't have labels. And then finally, we make a predictions array by passing the test data batches to the predict method called on our model. Whew. We got 3 steps there, but we can do them. We can tackle them one by one. How about we start with the first one? That's pretty logical. Load test image file names. what could we do? We could go test file names, nice and simple, equals, actually we might set up the test path. How about we do that? Test path equals, and we'll just copy it here to save us writing it out twice. Copy path, that's a little handy tip you can do there. You can paste. We don't need content. We could just keep it there if we wanted to, but I'm going to remove it so it's consistent with the other paths that we have. And I'm going to put this one here. So that's my path to the test folder. So now we're going to go create a little list comprehension equals test path plus fname, file name, for fname in os.listdir test path. Now we've seen this before when we were creating the original training file names, but let's just remind ourselves what it's doing. So os.listdir is just going through, or list directory, that's what it's short for, is just saying, hey, Python, get me all of the file names in this folder. And then we're creating a list which appends the test path, which is this, or adds together the test path plus every single file name in the test folder. Let's have a look. If in doubt, run the code. Wonderful. So now we've got the file names towards our test data. We can tick that off. Get our green tick emoji. This notebook is going to be full with them by the end. Okay, now we've got it. What's our next step? Convert the file names into test data batches using create data batches. Oh, I said date there. That's wrong. There we go, we'll fix it up. First of all, let's just do a length check of our test file name, see how many images we have. 10,357. Wonderful. So now, to create a data batch, it's pretty simple. We just bring in our function, we go test data. We'll write a comment here before we get started. So create test data batch. And we're going to go create data batches. Oh, it knows what we're talking about. And then we're going to pass it the test file names. And we're also going to see there's our test data, boolean. So we'll go test data equals true. And we'll run that. Wonderful. We get a little printout saying creating test data batches. Such a great function that we wrote. Let's come up here and have a look at it again. Turning our data into batches. So we've got a function create data batch or create data batches. And what does it do? If it's test data, which it is, it prints out this little statement. And then it goes, hey, turn our file names into tensors and then use from tensor slices to convert it into a tensor dataset. And then create a data batch by mapping the process image function. Remember, we don't pass getImageLabel to the test dataset because there's no labels with the test dataset. So we process our images just like we did on the training data, and then we turn it into a batch. In our case, batches of size 32, so that it can be computed really fast on with our GPU. So let's come back to where we were. That's what we've got. And if we go test data, it's a batch data set of shapes. So there's no labels here. These are just images of 224 by 224 by 3 for the color channels of type TensorFlow float. So beautiful. We've got our test data in the form of tensor batches. That's what we're after. And now, the finale. We can come up here. See how handy writing our functions to begin with has helped us out. We've created a full model. We've created a data batch in one hit. Now we've got to make a predictions array. So, how can we do that? Make predictions on test data batch using the loaded full model. All right, so test predictions equals loaded full model dot predict test data. We're going to set this to verbose equals 1. Excellent. Now, I kind of have to warn you that this is going to take a fairly long time. Reason being is because, let's put a little note here before we run this cell. Note, calling, even though we're running on a GPU, this is just like training our full model. So calling predict on our full model and passing it the test data batch will take a long time to run. And then it's going to be something like about an hour. We'll just go about 1 hour. That's what I found anyway. Reason being is because we have another 10,000 images here. And what we have to do is get our loaded full model, so all of the patterns that our loaded full model has learned in the training data set, it has to go through those, process the 10,000 images in our test file names or our test data batch, and then make predictions on those based on the patterns it finds in that test data. So we've set verbose equal to 1, so that when we run this, it's going to give us another little time step to update us about what's going on. So, without any further ado, let's run this and wait for it to load, and then we'll do the same thing again. I'll speed up the video so it'll be like instantaneously loaded for you. In reality, it'll take you a while to run this cell. In reality, it'll take me a while to run this cell, but I'm just doing it to show you it loading up, creating an ETA message, and then going through making some predictions on the test data. So we'll just wait a little while. This is going to go up. There we go. So ETA about 38 minutes. It has to go through 324 batches. And so that is because if you go 10,357 divided by 32, it's going to round that up to 324. That's where that number comes from. Okay, so I'm going to wait for this to go through. You might have to wait for it to go through as well. You don't actually have to wait. I'll be back in a few seconds. So I'm going to pause my video here and I'll be back in 3, 2, 1. And we're back. Now, I've gone and done something a little bit cheeky here. As you see, we've got about an hour left. But I figured, rather than me sit here and wait for this, I've actually, like any good chef has done, I've prepared a dish earlier. So I've actually gone through this process and waited the full 1 hour to go through. And now you could wait for yours to go through, but if you'd like to download a pre-made CSV of the test predictions, I'll attach that in the resource section so you don't have to wait that full hour to go through. And now I probably should have told you this before running this cell, but it's a good thing to sort of just get your feet wet and then figure out a better way of doing things. If we wanted this to save test predictions to a CSV file after it runs through, because if we waited a full hour for it to go through and then we somehow, our runtime disconnected and it didn't save, that'd be pretty disappointing. So what we can do is use np.saveText, this function here, to save, will this load a docstring while this is running? I don't think it will. But what this is going to do, oh, we forgot this, preds array. So let's just say that this finished. If I ran this cell after it, it's going to save test predictions, so this NumPy array, which is a prediction probabilities array, to this file as a CSV with a delimiter, comma, for comma separated values. And then once it was saved, it's going to appear in our files as a predsarray.csv because that's the file name we gave it. And then we can use np.loadText to load it back in. So what we'll do, rather than wait for this to finish, I'll just show you that in action. So these are some prediction probabilities that I've made in the past with a full model. So I'm going to stop this. Had about an hour to go. So again, my estimation is going to take about an hour is incorrect. So keyboard interrupt, there we go. So we're not going to run that because I've already saved this to predsarray, but I am going to run this. So let's pretend I've run this after this cell has completed, so this ETA has reached 0. So I'm going to load in this array from a CSV file. Beautiful. Now let's have a look at the first 10. There we go. So these are all prediction probabilities for the 10,000 images. So let's have a look at the shape of test predictions. $10,357, so that's how many test images we have. And each one of them has 120 different prediction probabilities. Now we've seen these values before. And so, remember, I've just taken this, let it run to its extent, save the CSV to a file that I've done earlier, as if we've cooked something earlier, and then I've just reloaded it in here. If my runtime disconnected, I'd want this file to be saved somewhere that I can access it later. And so, what's our next mission? If we wanted to submit this predictions array to Kaggle, what would it have to look like? So the sample submission is here. Oh, something went wrong loading your data. That's not very fun. But luckily, I've got this file in Dogvision, and it's a CSV. And so all I've done is I've just downloaded it and opened it in Google Sheets. So this is what it looks like. This is the sample submission. We need to get our predictions array into something like this. So an ID column, and then a column for each of the different dog breeds, and then their prediction probabilities. So that's what we'll work towards in the next video. We'll get our prediction probabilities array for Dogvision, or we're actually going back to the Kaggle dog breed identification format. So we'll get it set up like that so we can make a submission to Kaggle with our predictions.